Welcome to the vFRA Reference Architecture Data Modernization Data Movement screencast. In this screencast, we'll cover the batch production environment setup and overview. We will, in particular, set up our vPostgres staging, reporting, and job databases. We'll load the staging database with about 500,000 orders, and then we will deploy our worker application to the TC server cluster, run the batch job with one cluster member, and then deploy another cluster member and compare the performance before and after. So the first step is to copy the contents of the vFRA vPostgres server folder from the distribution to your vPostgres server. So I'm currently logged on to the server, and I'm going to go ahead, I'm in the bin directory. I'm going to first create the databases in the Postgres server. So I'll execute create batch dbs.sh. And then my next step is to create the batch tables. Go ahead and do that. So the next step is to actually load the staging data, and I'll do that by executing load batch staging data.sh. Now this will take a little bit of time, so we'll wait for this to complete. So the load is completed, and I've confirmed that by connecting to the batch db stg or staging database and issuing a select count, and I can see that there are 500,000 orders that have been copied to the staging database. I can also see that in my reporting database I have a reporting schema and an order table as expected, and in my job database there is a set of tables under the default schema from the Spring Batch job repository schema. So I'm ready to deploy the worker application to my TC server cluster. I'm going to use Hyperic to do that. So I've followed the instructions from the vFRA setup document to create a group for the batch application. So that's the first thing I'm going to do is go to Resources Browse and select Compatible Groups Clusters. And here's the group that I have defined called TC Server Batch Group. And I've already added a member to it, TCS01. First thing I need to do is go to Views and then Application Management. So I deploy an application from this screen, but before I do that, I am going to go and build my application. So here I am in the root directory of the vFRA distribution. I'm going to cd into vFRA build, or rather batch, and you can see that this is a Maven project because we have a pom.xml. So I'm going to build the modules in this project by saying maven clean install. So my build completed successfully. Now if I cd into the batch worker folder, and I can find the WAR file that was built here. So this file, vFRA batch worker, is the one that I need to upload via Hyperic. I'll choose the file that I just built and go ahead and open that, and I need to use the exact same, well, the context path has to match exactly the name of the file, at least without the build version. So I enter vFRA batch worker, and then I say upload and deploy, and I wait for it to upload. Now my deployment just finished successfully. I can see here that the status is successful, that it was deployed to the one member of the group, and that it's listed here as one of the deployed applications. So one thing I can do to test that the application's up and running is also visit, there's a simple ping application. So I'm at the home page of the TC server on TCS01. I can navigate in the browser to the application, and there's a ping app that will simply return a string ready for work. Now that I know that TC server is up and running, the app's up and running, I can take a look at the load balancing setup in vFRA web server. So now I'm on the VM where I have installed the vFRA web server, and I'm in the root directory for the install, and I've already used the new server.pl command to create a vFRA batch web server. So if I change into that directory and go into the conf directory, and I've already made some edits to the httpd.conf file. I'll just quickly take a look at that. So I have this is by default enabled. There's a load module for the proxy balancer module. If I go to the end of the file, I've added a single balancer member, the TCS-01 VM, to the proxy configuration. And so that means that it's going to essentially just forward requests to that one TC server at this point. And now I want to restart the web server, so I'll go to the bin directory and issue a restart command, and that will make the changes that I've made to the config file take effect. And one more test, I'll actually use the URL of my web server and try the ping command for that, and it works. So I know that it's successfully forwarding requests to the TC server instance. So now I'm ready to actually run the master script. I'm back on the machine, my local machine that I've built the WAR file on, where I have my distribution, and I am going to CD into the, let's see where I am right now, into the batch core module, because that's actually where I have the configuration to run the master script. So from here, if you look at the setup instructions, there's some detail about setting up the property files for the database connections. And then I'm ready to run my shell, which is called copy orders job.sh. So it sent out the requests. It's actually using a partition size of 4. So that means that it will split, it being the master partition handler, will split the input from the staging data into 4 separate sets and send 4 requests to the cluster, and the load balancer will forward all 4 of those requests to the single node that's now running in the cluster. So if I connect to the reporting database and issue a select count on the reporting.orders, I can see the progress of the job, and I can see the count of orders that have been copied of the 500,000 slowly reaching its goal. And now I can see that the job has completed. The running count has gone down to 0. We've had 4 successful executions, and that makes sense because we have 4 partitions and therefore 4 step executions. So I'm going to look at the details of that last job execution using the Spring Batch admin app that I built and discussed in the developer intro. So in this case, I have the app running in my local STS environment. I changed the database settings to point at the production database, so I can actually say, I can click on the executions. I can see the job that I just ran. It shows a status of completed, exit code completed, and I can see that the entire job took 9 minutes and 49 seconds. I can dive into some of the details of the executions. So in this case, it shows that it always lists a master or parent step, and we can see that I had 4 child partitions and the time that each one of them took, and the number of records that each one of them wrote, and the number of commits involved. So now we've done the base test of running 4 partitions on a single node, and we know that because of how we've configured the thread pool that they were executing in parallel. Our total time was 9 minutes and 41 seconds. So now what we're going to do is increase the partition size to 8 and add another thread, or rather add another node to the cluster and see what kind of improvement we get. So now I'm going to add a new member to the TC server batch group. I can go to inventory while I'm in the batch group context in Hyperic, and I can say add to list, select a runtime which already has been created, press OK. Now it shows under inventory that I have both members added to the group. So the next step is to deploy the application to my new member. So I'm going to actually select it specifically, and from this context click Views, Application Management, and then deploy my app to the specific server. My application has deployed successfully. If I go back to the TC server batch group context and look under Views, Application Management, I can see that the batch worker app is now deployed to 2 out of the 2 servers. Now that I have a new TC server member, I'm adding it to the web server cluster configuration. So here you can see under my proxy element, I have a new balancer member pointing to TCS02. And as before, once I save this file, I'll go ahead and restart the server. So now that the load balancer is configured, I can ping my new server. I know that it's available. I can also ping the load balancer endpoint. And I know that it's working. I can do it multiple times and see that it's distributing the requests to the 2 members. So my final step is to run the master script, but before that I need to edit the partition size properties and do a Maven install. So I'm in the batch core project, and I'm going to edit the vFRA-batch properties file and increase the batch partition size parameter to 8. And then I'm going to do a Maven install. It'll copy the change property file to the target directory, and then run my copy orders job shell again and compare the performance as soon as this is done. I'm back in the batch admin, and just wanted to note that you can also check the status of a job through the admin UI. So I can see here that I have a job started. There's no exit code known at this point. I can go look at the partitions. I can see there are 8 child partitions in various states, and I'm able to update this and get a count of written records as well. So my job completed, and I can see that it took 7 minutes and 45 seconds, and I had 8 partitions, and they divided the records evenly among them. Now if I compare this to my previous job, so the first run was 9 minutes and 49 seconds. That was with 1 cluster member, partition size of 4. My most recent job executed in 7 minutes and 53 seconds with 2 cluster members and a partition size of 8, so that would be 4 per member. So that's definitely an improvement. However, the best time I got was for a partition size of 4 distributed across 2 cluster members. So that's for both of these timings having to do with 6 minutes and 37 seconds and 6 minutes and 57 seconds. So if we look at one of them, we can see that there are 4 partitions, so there was some level of contention involved by having more than 2 partitions per node that outweighed the parallelization of having more concurrent processing going on. So that concludes the production overview screencast, in which we went over the setup of the Spring Batch solution, deployment, scaling out horizontally, and realizing performance improvements in our batch job.